Okay, so in this part we had to show minus n times 2n plus 1, and that's what we showed. Let's move to the next part now. So here you have to find the limit as n tends to infinity to 2n over n square. So we already have proved the S2n formula in previous part. So we plug in S2n equals to minus n times 2n plus 1, and we divide by n square. Now we have to divide each like numerator and denominator both by n square. So that's what I'm going to do. N times 2n plus 1 over n square, and n square is already there, and I have to divide by n square. So if I simplify the numerator, I'm going to get minus 1 over n and 2n plus 1, and in the denominator I have 1, and this can go inside the bracket. It will be minus 2 minus 1 over n. Now as n tends to infinity, we can get minus 2, because minus 2 minus 1 over infinity is minus 2. So if we look at the second part of the question, in which we have to find the limit as n tends to infinity of s2n plus 1 over n square. It's almost the same thing. The only difference is that we have to realize that we have to add one more term to it in the previous sum. So the sum is basically minus 2 times, it's n minus n times 2n plus 1. And we have to add one more term to it, which is one new term. So the term should be, since 2n is even number of terms, as 2n should be sum of even number of terms, we have to add one more, means we have to add one odd term. So the term formula we already know, as for the odd term, is 2r minus 1 whole square. So this is what we are going to add, and since odd terms are positive, so we have to add just a positive term here. So this is going to be plus 2n minus 1 whole square, and this whole thing is divided by n square, and we have to apply the limit as n tends to infinity. So we better simplify this first. So if we open this bracket, so it's minus 2n square minus n plus 4n square minus 4n plus 1 divided by n square. Simplify the terms. So this is going to be 2n square minus 5n plus 1 over n square. Now I can break the LCM. I'm going to get 2 minus 5 over n plus 1 over n square. If I apply the limit as n tends to infinity, I'm going to get only 2. And that's the answer.